Welcome back. Let's talk about Newton's third law. Newton's third law is something that you're familiar with. You've heard it before. For every action, there's an equal and opposite reaction. But we're going to be more specific and say that for every action force, there's an equal and opposite reaction force. And what that means is I like to say that you can't touch something without being touched. In other words, if you touch the wall touches you. If you push on the wall is going to push back on you with equal and opposite force. Also, remember that forces are also can be a pull. So if I take these two spring scales and if I pull on one, the force reading is going to be the same on both. So if I pull up and just hold this one that's on the bottom, they still have the same force reading. They're still showing about 12 newtons of force. So again, you can't push something without being pushed back. You can't pull something without getting pulled back in the opposite direction, even though I'm not actually pulling on my bottom spring scale. Okay, but you cannot. Forces exist in pairs. So when I pull up, it pulls back with equal and opposite force. So basically, that says that Newton's third law, Newton's forces always exist in pairs. They're always equal in magnitude but opposite in direction. So the ball hits the wall hits the back, hits back on the ball. Think about walking. This gets a little tricky. When you walk across the floor, you push down on the floor pushes back up on you. Equal and opposite. Then how come we're able to accelerate forward? Well, now we have to think about Newton's second law. Newton's second law tells us, remember, that basically heavier things or more massive things are harder to accelerate. When you push against the ground, really you're pushing against the earth. Are you going to cause the earth to accelerate? No. But can the earth cause you to accelerate forward when it pushes back on you? Yes, because you certainly don't have as much mass as the earth. So you have to think about Newton's second law and as well when you think about moving and those unbalanced masses which can cause an acceleration. So you can push on the floor pushes back on you, and you do fortunately accelerate because you have much less mass than the earth. There's another classic physics problem, the horse and the cart. Well, Newton's third law tells us that not all forces that are equal and opposite are third law force pairs, because sometimes those forces act on different objects, and you have to consider all of the force pairs and the net force for all of the pairs that are existing kind of in the system. So the classic physics problem is the horse that refused to pull the carts, and the horse was smart. The horse knew Newton's third law, and the horse said, I'm not going to pull the cart because if I pull on the cart's going to pull back on me, and no, nothing's going to happen. But what the horse didn't realize was that there was another force pair that could cause that cart to accelerate. If the horse pushes back on the ground, and the ground pushes back on the horse, and if that force vector is more than the cart pulling back on the horse, then of course the horse will accelerate. So forces on different objects do not always add up to zero, and these force pairs can have a greater net force causing the horse to accelerate forward.